We have talked a bit, many times, about what we understand to be true and what we understand to be uncertain about climate change and the models that are used to generate what we are told by many are consensus, right, in the scientific community. And in part, what is absolutely true is that models requiring that assumptions be made about what you weight and what you don't weight and what you think is important and which data sets you use and such inherently will spit out conclusions that are consistent with the assumptions that you fed into the models. This is just a fact of using models. And so it is alarming, frankly, that we can be assured that there is nearly complete consensus across all scientists of the conclusions of the climate change models, given that it is models that we're talking about. Like anytime, and if you didn't know this already about science, COVID should have revealed this. Anytime you are told, follow the science, do the thing that all the scientists know is right, there is a really good chance that there is some obfuscation going on. That's not how science works. New studies suggest global warming could be mostly an urban problem. A new study published in the scientific peer-reviewed journal Climate by 37 researchers from 18 countries suggests that current estimates of global warming are contaminated by urban warming biases. The study also suggests the solar activity estimates considered in the most recent reports by the UN's Intergovernmental Panel on Climate Change, that's the IPCC, likely underestimated the role of the sun in global warming since the 19th century. Okay, so that's the proceed. That's the very short version of what these researchers claim to have found. And there are, again, two papers. One of them is still in preprint, and one of them in the journal Climate has been published. And I want to spend a little bit of time talking about the paper that's been published in the journal Climate. Okay, it's one of these papers with a ton of authors. The first three in the author list being the prime sort of drivers behind the Ceres Institute. And then there's a whole bunch of other researchers from across institutions around the world, including some independent researchers. So from the abstract of this paper, we have a statistical analysis was applied to Northern Hemisphere land surface temperatures from 1850 to 2018 to try to identify the main drivers of the observed warming since the mid-19th century. I'm going to keep on stepping out for editorializing. No one is suggesting that we haven't been warming since we started taking data in the mid-19th century. Two different temperature estimates were considered, a rural and urban blend that matches almost exactly with most current estimates, and a rural-only estimate. The rural and urban blend indicates a long-term warming of 0.89 degrees Celsius per century since 1850, while the rural-only indicates 0.55 degrees Celsius per century. This contradicts a common assumption that current thermometer-based global temperature indices are relatively unaffected by urban warming biases. Okay, let's just stick to that one for the moment, if you would give me my screen back. And that's sort of half of what this paper is doing. It's well recognized that cities are hotter than surrounding areas. We know some of the reasons for this. Maybe we actually have a really good fix on all of the reasons, but higher density, lots of black surfaces that reflect, albedo is not our friend in cities, things like this, right?
So wait, they absorb energy from the sun because they're black. Mm-hmm. If you think about
cities.
Yeah. Mm-hmm. If you think about an air conditioner cools a room, but it creates more heat. The net output is heat. That heat ends up in the city.
Right.
Cities.
Yes, buildings in cities are maybe cooler than the surrounding countryside, but the air outside in cities will therefore be hotter.
And obviously they're not measuring the temperature inside of apartments. They're measuring it outside. Right. If you think about the canyonizing effect of buildings. They will prevent that heat from dissipating at any normal rate.
Boundary layers being what they are.
Boundary layers being what they are. So these are reasons, and think about every car going down the highway is putting out hot gases. Even a car that isn't putting out hot gas, I said every car, it's not quite every car because we've got electric cars in which the heat that is produced by the generating of the energy, if it's, let's say, coal power that's producing the electricity, is elsewhere. But nonetheless, the car is moving air molecules. It's literally warming the air as it moves. The tires are creating heat. So all of these things are generating heat, and it will be concentrated where human activity is concentrated, and we call that thing a city.
And this is this is not controversial for anyone. Like, it is completely well understood and demonstrably true that cities are hotter than surrounding areas. Urban areas are hotter than rural areas. We know this. But urban heat, the fact of urban areas being hotter than rural areas, has been dismissed by mainstream climate scientists as trivial and contributing to our understanding of a warming climate. On what basis it's been dismissed, I don't even know, right? Because what this research, and presumably someone does, but what this research that we're talking about now that was just published in the journal Climate, I think it was at the very end of August of 2023, and these researchers look at temperature estimates only from rural areas rather than from the urban-rural mix that pretty much all of the other models are looking at. They find that 40% of the warming since 1850 is attributable to urban heat. Now, that's A, not all of it, and B, that's not nothing, because we still have a problem where cities are hot and they're getting hotter. This still is a significant fraction of warming to be explained, and cities being hot is a problem for a number of reasons. But it does suggest that rural areas are not warming at the rate that we have been told the entire globe is warming, because what you have is a lot of data being taken from urban areas.
So I want to interject something here.
Go for it.
It is true that cities are warming and that that's a real phenomenon. It is false to the extent that any pattern of climate change is deduced based on city warming. That is false. It is a little bit like the conditions in an apartment. If you took data from inside the oven, you might get an alarmist picture of the conditions inside the apartment. It is not that the oven isn't real. It's not that it's not generating heat. In the case of an oven on an interior wall in an apartment, it's not even that all that heat doesn't ultimately end up in the apartment. It does, but dissipated over a very large volume. It's not a critical matter.
Yep.
And so the ultimate underlying question here is, how critical is what we face? And to the extent that it is critical, what is its source?
Yeah. So here's a bit from pages 9 and 10 of the paper with regard to this particular set of results that they've got. In this study, we proceed with the two temperature series described above, that is the urban and rural, like all of the temperatures since 1850 through 2018, and just the rural areas, which is a tiny fraction, incidentally. It's only 14% of all of the temperature stations. So we got all of it versus 14%, but the 14% are those which are in rural areas. A visual comparison, I'll show you the visual comparison after I read through this. A visual comparison of the two series shows that while there are clear similarities between the rural and urban and rural-only estimates, there are also several key differences, and they identify three. One, the rural-only estimate is noticeably noisier, i.e. the magnitudes of the fluctuations from year to year are larger. This is largely a consequence of the reduced number of stations. However, it is noteworthy that the timing of the multi-decadal warming and cooling periods for both series are qualitatively smaller. So with regard to this first point about greater noisiness in the data, this will always be true when you have a data set that's smaller. The larger your data set, the lower the impact of noise, of outliers, of fluctuations that will happen in terms of your ability to actually read and interpret the data set.
So this is the reason that the pseudoscientific religion that embraces randomized controlled trials as the only source of reliable information. This is the point that they are actually not wrong about that. Large data sets drive out noise, so you can see subtle patterns. So anyway, that is why we collect
The more
large
subtle
amounts of-
the actual pattern, the more likely a small data set is to obscure that subtle pattern by virtue of the fact that there will be noise that will overwhelm subtlety.
And just for the sake of completeness, when we used to teach signal to noise ratios as professors, it is important to understand that noise is not an actual phenomenon. Noise is the sum total of the effects of all of the things that you're not trying to study.
Yeah.
So it shows up as some random influence or maybe a systematic influence.
Right. And it's not, sometimes there will be error in data collection, right? But but climate and weather are understood to be different things, linked for sure, related for sure, but at different timescales. And so, if what you are trying to figure out is there a longitudinal pattern? Longitudinal just referring to long there is the time dimension, right? So if what you're trying to figure out is there a pattern over 150, 200 years? The fact that in 1910 such and such had a really hot summer and a really cold winter is not relevant. The people living then will have felt like, oh my God, this feels like the end of everything. But it doesn't necessarily play into the longitudinal data.
So let me give a different example that will illustrate the noise point. Let's suppose that you were trying to study the change in symptoms associated with a virus across time. And so you were looking at data sets, but you had a population that wasn't totally genetically homogeneous. You had people from one origin living in one part of your sample area and people of another extraction living somewhere else. The genetic differences between those people is something that you didn't measure and maybe didn't even think about, but to the extent that it can affect how a virus impacts people, for example, COVID had a bias with respect to blood type.
Right.
To the extent that blood types are not perfectly evenly distributed across the population, if you sampled in such a way that you happen to capture more people with O positive blood in one part of your sample, it would show up as noise relative to the actual pattern you were trying to study, which is how virulent is this particular variant of the virus.
But one experiment's noise is one scientist's noise is another scientist's hypothesis.
Yep.
And so you can look at data sets that appear to be very noisy with regard to something and say, let's dig there. Let's figure out what there is to be explained there potentially.
And actually, what you're pointing to is the perfect example of this, because in effect, if you're asking the question, what is the temperature doing over time? And you are not thinking about what is the population doing over time. Oh, it's concentrating heat in these little places where we also tend to measure temperature. And the point is, it's noise until you decide to study that impact. And then you discover, oh, actually, one of the factors that was influencing what we thought was going on with climate is actually urbanization.
Right. Okay, so again, here we are in the middle of this paper they are talking about three findings that they get when they compare the urban and rural data set from 1850 to 2018 to the rural only. We talked about noise. Number two is the long-term linear warming trend of the rural and urban series is 62% higher than that for the rural only series. And we've already gone over the numbers. This paper published in 2021 by the same authors of this paper, many of the same authors, argue that much of this extra warming in the rural and urban series is due to a combination of urbanization bias and urban blending arising from the homogenization process. So we've already sort of covered much of that. And then three, while the rural and urban series implies an almost continuous long-term warming, the rural-only series suggests a much more non-linear behavior. That is, the rural-only series suggests that temperatures have alternated between multi-decadal periods of cooling and periods of warming since at least the mid-19th century. Figure 3A from this same paper, Soon et al. 2023, published in Climate this last month. This is the visual accompanying what we were just talking about, the comparison of rural and urban with rural-only estimates, where the rural and urban, which is what you what you will tend to hear about in most climate change models, and what we are told there is nearly complete consensus about from climate scientists, is in red, the non-dashed line in red, for those of you with color inferiority. And the data that these authors are using, which is again is a tiny subset of the data that are used generally, but what they have selected out is the urban places. So the rural only data with a blue dashed line shows again it's noisier. Your peaks and your troughs are higher. That's the noise, but also not with regard to noise, but with regard to the non-linearity, the less linear nature of the change. The red line is more or less going up over time. The blue dashed line, using data only from the rural temperature stations, it does a lot more going up and down. That said, beginning in about 1970. We see what looks to me, and I'm not doing the math on this. They do some of it later in the paper, but I don't remember whether they say 1970 looks like an inflection point with regard to either model, right? So urbanization bias in the standard ways that we are informed about climate change, yes. Does that mean that there is nothing to be found in an assessment that the globe is warming? No. But is there a number? Is there bias in what we are being told, and is there a pattern that is being obscured by using data from places that really it shouldn't be used? And here's one more reason that we probably should be, that we absolutely. I'm just going to say absolutely should be suspect about using these urban weather stations, these urban temperature stations, is that we've got data here from 1850. Now, not all of these weather stations have been in use since 1850, of course, but many of them were and have been in continuous use since then. How many of those that are urban now were urban in 1850? Right? So what you're going to find is a warming trend regardless, because they went from rural to urban, and we know that cities are hotter. And so even within a temperature station, if you have urbanization around that temperature station, you will get a warming trend no matter what is happening more globally.
Yeah. All right. Now how to put some of these things together. One, as I mentioned to you when you first pointed this paper out to me, this result did not come as a total shock, because I had had a conversation with Creon Levitt, former NASA scientist, on this very topic based on different data.
And this is not a public conversation.
It was not a public conversation. He does have he's written up what he was looking at, and I will put a link in the description, or I will give it to you and you will put a link in the description, since you compile those things. But anyway, he wrote up his analysis, and what he looked at on the basis that the data sets that are traditionally used for calculating warming are understood widely by people who are skeptical to have a lot of monkey business in them, that there's a lot of adjustment in things that is not necessarily justified by rigorous scientific logic. And so he looked for a data set.
The modelers will say we always manipulate things, and manipulate would be a wrong word, but you're saying actually it's widely understood that this level of tinkering is not justified by their explanations for why they're doing it.
Right. So let's give an example of why tinkering might actually be justified. Let's suppose that you were collecting temperature data from a bunch of sensors that you had distributed around some landscape. Let's suppose it had nothing to do with global warming. You were just measuring temperature because you were interested in some ecological phenomenon.
Phenology. Which is related to climate, of course. But when do plants of a particular when do deciduous huckleberries flower every year in the Pacific Northwest?
Right. So maybe you would be
related to temperature?
You'd be looking at microclimate, and so you would have distributed a bunch of sensors, and then you would take their data and you would correlate that data with measurements that you took some other way about what was flowering. Okay, so suppose on some day you get an average temperature of, I don't know, it's in Fahrenheit, let's say it's 75 degrees. But one sensor reads 0. Okay? That sensor is broken. If you include the 0, your data set is worse than if you exclude it. You have a totally legitimate reason to throw it out. You know it wasn't 0.
Yeah.
So that would be an obvious case. Now, you could also do other things.
And what if it says 58?
Right.
And everyone else, all the other sensors are in the mid-70s.
Right. So you could throw out the outliers that are far enough out that they're suspect. And, based on what it was you were studying, you would have to be careful not to throw out data that's actually informative. But
I mean, this is always, so I know you were going somewhere specifically, but this is always the problem with throwing out outliers. That you say, well, okay, 0, that's broken.
Yep.
Right? 200 degrees Fahrenheit, that's broken. Like that, those are broken.
Yep.
But within, say, 3 standard deviations of the norm, it's broken, maybe. But if you start whittling away the outliers until what you get is an answer that looks right to you, what looks right to you starts to become a much more narrow field, and you yourself as a scientist become canalized, and then your data become canalized, and then you can only see one thing, and you're no longer operating as a scientist.
Yeah, in fact, we've mentioned this before, but there's a marvelous exploration of this and related topics by Feynman called Cargo Cult Science.
Yeah.
And he talks about the fact that very important scientific discoveries have been delayed by the fact that people were throwing out the evidence that they were true because it violated their assumptions about what was possible. So I can't remember if it's Maxwell's equation. I don't remember what the exact example was. But anyway, it's well worth looking at this because the point is, on the one hand, in order to do good science, sometimes you got to throw stuff out.
Right.
On the other hand, you can certainly talk yourself into validating a false belief. So this has to be done by people who are scientifically rigorous and know when to be surprised and know when to just throw something out because it couldn't possibly be right. So anyway, those are important influences. Now, what Creon did, and again, we will put the link to this in the description here. But what Creon did was he looked at a different data set that was largely ignored and therefore hadn't been tinkered with. And the data set has to do with the measurements of temperature and other parameters at airports, where these things are rigorously monitored because they are relevant to aviation. You can, in an extreme case, you can think about the likelihood that there is ice on the wing of an airplane is a life and death thing. And so there's a whole system for monitoring these parameters so pilots know exactly what's going on. And what Creon found, very much consistent with this paper, but maybe even more extreme, is that
with this paper that I'm talking about, Student et al. 2023,
was that in places he compared, for example, after talking to me or thinking about our podcast, he looked at Portland and found warming, and then he looked at is it Camp Pendleton, but an airport that had no development around it, and he found that the warming that he indeed saw in the Portland measurements evaporated when, or probably evaporated. Of course, there's noise in both data sets, but appears to have evaporated when he looked at a what should have been a climatologically similar location that had not experienced a development over the same period of time. So anyway, this is exactly how you would go back and correct an error that had come from the fact that your measurements were biased towards urban, and therefore, of course, ended up showing you warming.
Yeah. And we all should want to have our scientists behaving this way, and we all should want to know. We all should want to know what is actually true. We all should. Okay, so that's one of the big pieces of this paper, is about the urbanization bias in the data sets, and therefore the models that use those data sets that include temperature station data from both urban and rural areas since 1850. The other one is, here. So this is from, again, the beginning of the paper. The main authors of this paper, from a paper in 2021, anticipated two major problems with the IPCC's, what does AR stand for? Sorry, I've forgotten. I have to go back. There, it's basically the Intergovernmental
Report.
Panel on Climate Change annual assessment report. Assessment report. Okay, good. So they had done assessment report 5, and they were about to do assessment report 6. And these guys wrote a paper in 2021 that came just late enough for the IPCC to not include their recommendations in their next report in AR6. They anticipated two major problems, Connolly et al. Did, if AR6 repeated AR5's approach, which of course it did. Those two major problems that they predicted were, one, this is what we just talked about, urban areas represent a small fraction of the global land area, yet the land component of the IPCC's global temperature estimates include many urbanized weather stations. As a result, there is concern that they might be contaminated by urbanization bias, i.e. warming biases from the growth of urban heat islands around weather stations. So we've already gone through that one. That's just a recap. 2, Maths et al., don't know if I'm pronouncing that correctly, the total solar irradiance TSI dataset recommended by the CMIP6 organizers for estimating past solar activity is a low solar variability estimate, just like the 4 datasets considered by these other modeling groups for AR5, and implies a much smaller role for the sun than using a high solar variability dataset. Let's explain for a moment before we read a little bit more on this paper. What are the potential contributors to climate, and specifically to global warming? There are many, but broadly speaking, we have anthropogenic, we have human, we have sun, and we have volcanoes. Okay, we have volcanism, solar, and anthropogenic, and they do talk about some of the contributors of volcanism in this paper, but largely we're going to talk here about human versus sun, because those are the two biggest ones that are being talked about.
So you said human, volcanic, and
Sun.
And sun, and so I know you're not excluding it because I know it's definitely on your mind, so it must be buried in one of those. But it seems to me that there's a fourth category.
I think there are many categories, but what like? I'm on tenterhooks here. What?
The orbital dynamics.
Okay, sure.
Of the Earth.
So the point here is not that there's a lot of other things. We're not talking about volcanism either. Yeah. So the Milankovitch cycles. Maybe even that's included in solar.
They must be including it in sun.
Right. So
it's not what the problem is that sun is two things then. The sun is what's the sun putting out, and then the sun is also what are we receiving, which is heavily contingent or
just so volcanism is the simplest of those three, right?
Yep.
Like what are the ways that humans could be affecting climate? Wow, it's not just one thing. It's not just 3 things. It's not just 8 things, right? Similarly, maybe rather than sun, it should be called astronomical influences. And I don't know what all is included. These are data sets and models that are so multivariate that basically not a climate scientist. I don't know what all is included. But if you assume, if you say, okay, let's put aside, let's just imagine for the moment in a simple universe, which is not the one that we live in, the only possible effects on climate are humans and sun. If you say, well, the sun doesn't change that much, therefore, and that would be a low solar variability model. The sun doesn't change very much in terms of how it affects the Earth. You will inherently then increase the relative impact of humans on any change that you see. If you've only got those 2 things and you say low solar variability, the sun has an impact for sure, but it's pretty much consistent over time, you have guaranteed the outcome that the role of anthropogenic activities has a higher influence.
If I can say that another way.
Yeah.
If you were allocating total change to an artificially smaller number of causes, you will end up taking causes you didn't account for and putting it into those other modes where it doesn't belong. If the sun varies and you assume it doesn't, then you are going to end up including the variability that comes from the sun under some other causal mode that it is not attributable to.
Exactly. So these authors have used what they're calling a high solar variability data set. They're not the only ones to do it. They didn't invent it. These data sets exist out there and they're available to everyone. But they started not with the assumption that the sun varies a lot, but with the assumption that if we changed our assumptions going in about the degree to which the sun does vary, then we will end up attributing less of the change that we have seen to human activity. And that's a pretty basic assumption, and it's borne out, basically.
So I will say I now know why orbital dynamics don't show up, and I don't think they're buried in what the sun is putting out in their model. It's because on this time scale, they're irrelevant.
Yeah, that's right.
The change is too slow.
Yeah. Okay, so a little more from this actual paper. So again, we've got the IPCC, which comes out, I don't know what the periodicity of their annual reports or their attribution. What was the ACE for? Assessment reports, thank you. I don't think so. They can't because they're only on 6. So the IPCC, between putting out its assessment report number 5 and assessment report number 6, this Connolly et al. 2021 paper was published, and they said, here's some things you need to be concerned about: urbanization bias and your low solar variability models, data sets. And the IPCC said, you came too late, and maybe they did. Apparently 10.5 weeks too late. We can't include that in how it is that we're going to go about doing this. But since then, since the AR6, since the assessment report number 6 from the IPCC has come out, there are a number, as they say here, a number of recent global temperature attribution studies have explicitly considered different aspects of that were mentioned in this 2021 paper in their analysis. 6 are mentioned here. 3 of these studies agreed with Connolly et al. 2021 that A, much of the long-term warming since the late 19th century could be explained in terms of changing solar activity, and B, the IPCC had substantially underestimated the solar contribution. 2 of the studies disagreed with Connolly et al. 2021 and concluded that the solar contribution was very small. The remaining study reached an intermediate conclusion, finding that TSI, that's the models that are being used, finding that TSI was the dominant climate driver up to 1960, but that afterwards CO2 appeared to dominate. That looks like science to me, right? We've got 6 published pieces of research since Connolly et al. 2021 published, and said, here are 2 major ways that the existing models are not being rigorous about figuring out, about teasing apart the various effects that might exist. 6 studies, 3 of which say, yeah, you may be right there. We're not certain, but you may be right. 2 of which say, yeah, we don't think so. We still think that the sun plays a minor role. And 1 that is intermediate, and it's not actually intermediate, it's basically got an inflection point. Before 1960, they say sun, and after 1960, they say actually carbon is their finding. That is what science, especially in a complex system, will tend to look like. We haven't figured this out yet. And when you tweak parameters in your model, you can get wildly different results, and that tells you for sure that the models are a big part of what is driving the, frankly, ideology of climate change rather than the science.
It's interesting. The complex systems problem here intrudes in multiple directions, and whether it is emphasized or de-emphasized is a political question. It shouldn't be. But what's happening here is you have a series of layered complex systems. The sun does not appear to be a complex system to those of us who look at it from the Earth, but it is one. And the likelihood that what it puts out is constant is, well, it's just simply false. You can tell that it's simply false because, for example, coronal mass ejections contain a lot of energy, and they are flung off the sun. There's a pattern in terms of how frequently they're flung off. They are haphazardly flung off in terms of direction. But the idea if this was a perfectly uniform illuminator of the Earth, you wouldn't have those kinds of effects, and they're clearly there. So the sunspot cycle.
Coronal mass ejections put the lie to low solar variability.
Right. The variability is there, and we can see it on many different timescales. We see a sunspot cycle, a sort of decade-like cycle. We see low periods of activity, within a year, high periods of activity. These things all suggest a highly dynamic, complex system that we do not understand.
Yeah.
It is not a complex adaptive system, right? Complex adaptive system is different. That's like biology, but it's a complex system like hurricane.
Well, things on the Earth are responding complexly and adaptively to warming that is happening.
Absolutely.
Right.
The sun is
Phenology range distribution, organisms moving north towards the poles where they couldn't survive before, things like this.
right. So yes, our reaction is there's a whole lot of biology and therefore complex adaptive systems interfacing it, but the sun doesn't know anything about them. It's just flinging out energy as it does based on the fusion that's taking place internally. But if you think about whether complex systems are going to be emphasized when we're being panicked about anthropogenic climate change, then of course the fact that we have this massively complex system that we are disrupting and therefore putting ourselves in danger is the star of the show, right? Whereas the complex system inside the sun, that means maybe we actually can't be entirely certain about what we think we're detecting, because even if we detect a warming down here on Earth, the question is that an anomaly of the data because it was collected in heat islands? Is that an anomaly of the sun that we don't yet understand, in terms of how much energy it was putting out? What can we infer from past solar environments based on indirect evidence in ice cores or whatever? Yep. So I guess what you would like, scientifically speaking, is a consistent response to complexity. Complexity ought to give you pause about what you think you understand, and that both puts us in danger with respect to disrupting complex systems of life here on Earth, but it also puts us in danger scientifically of getting stuff wrong because we were still at the beginning of understanding all of the inputs to it.
Right.
So our certainty should go down because we're looking at complex systems, and that increases danger, but it also decreases insight.
Yes. All true. All true. Okay. Maybe, though, these people are cranks. Maybe the people who did the research have an axe to grind, an ideological axe to grind, just like many have argued, those on the side of modifying all human behavior immediately and permanently due to rampant out of control anthropogenic climate change appear to have an ideological axe to grind. Let's see. So this is series. You can show my screen here. The Center for Environmental Research and Earth Sciences is a multidisciplinary and independent research group. Lots more good things to say. Here are three of the primary drivers at series. They're actually the three top authors on the paper. Their mission statement. In recent years, the scientific community appears to have prioritized defining a scientific consensus on any scientific topic, especially politically charged topics. We believe this obsession with forming a consensus contradicts the ethos of true scientific inquiry and open-ended scientific research. Sounds like loons to me. Instead, our approach to scientific research is driven by a deep curiosity to continually expand and revisit our understanding of important scientific topics. I think they're not following the science. I think that's their problem. So just one more thing from their site.
Following is not their strong suit.
Yeah, they're not followers. That's their problem. That's probably why, support us, it says. How we are funded. Just a little bit more about them. In our view, scientific research works best when it is independent. What? From industry, government, religion, politics, or ideology. For this reason, a strict requirement for all our patrons and funders is they do not attempt to influence either the conclusions or research directions of our group. Instead, we strive to ensure our research is driven by objective, evidence-based analysis, like that. Rather different from what many funders attempt and succeed at doing with regard to driving scientific both results, but more cryptically and maybe more importantly, the questions that are asked in the first place. So if certain kinds of questions are never asked, They don't have to get into the mud and actually change the results that are found, because they can just keep the questions from being asked in the first place. And that is part of why independent research groups like this one are so important.